Okay, so the wrap-up video for Unit 6, our test is Tuesday or Wednesday, depending on whether you have me A day or B day. So what I did was I went through the entire 500-page study guide, and I broke it up by each of the lessons that we've done. So lesson 1 and 2, which is the basic identity. So it has all the problems that pertain to that. You can see, and we can go over this. Okay, I'm going to just solve a couple problems from each of the lessons. Okay, and I want to show you that if you haven't done part 3 yet, you really need to do that. Okay, because a lot of our questions, some of my test questions are going to come from problems that are similar or have the concept of part 3. Okay, so let's get started. So for lesson 1 and 2, we did basic identities. Those will not be given on the test. So the things that I'm going to give you as reference on the test are going to be, I'm going to give you the entire unit circle completely filled out, because I'm not testing you on whether you know or not you know the unit circle. That was the prior test. This is going to be over how to apply and use the unit circle as a reference. And so it's pointless for me to, I don't think I'm testing you on that. That's not what this unit is about. I'm also going to give you the double angle formulas, identity formulas, and I am going to also give you the sum and difference formulas also. But the basic identities, the reciprocal identities, what else? The tangent, and then the Pythagorean identity, you are going to be responsible for. Okay, so we've done a ton of these. Okay, and in part 2, there is ones that say simplify, but this one right here is not simplifying. It's what am I trying? Oh no. Okay, it's not simplifying. It's proving or verifying left-hand side equals right-hand side. Okay, so let's do these 2 problems, only manipulating one side of the equation. Okay, so you can see right here that the left-hand side, I'm going to change the left-hand side because I already know, hey, there's a lot of fractions going on. So what I could do is combine the fractions. So I have 1 over 1 plus cosine of theta minus 1 over 1 minus cosine of theta. And you want to always kind of switch the side that is the messiest and kind of clean it up, okay? And then maybe make common denominator, which is going to be the conjugate of each, 1 minus cosine of theta. And then this is going to be 1 plus the cosine of theta and 1 plus the cosine of theta. And so I have 1 minus cosine of theta over, that becomes a difference of squares. So that's a 1. And I don't have to worry about the O and the I of the FOIL. I just have to do the first and the last. And then minus cosine square theta minus, remember there's a parentheses around this entire fraction with that subtraction sign. And that's one of the things that I noticed that you guys messed up the most on, that you have to distribute this -1. Okay, when there's a subtraction sign, there's 2 terms after it, so you have to distribute it. So we have a 1 minus cosine of theta, and that way I can combine this 1 minus cosine of theta over, we have a common denominator, and then the ones cancel out, and we have a -2 cosine of theta over 1 minus cosine square theta. Okay. We know that 1 minus cosine square theta. Remember, one of the most important identities is sine squared plus cosine squared equals 1. And that is a derivative of that, which tells me, need a little bit more space, that this entire thing is going to be sine squared theta. And why do I want to do that? Is because if I look, I need a cosine for the cotangent and a cosine in the numerator and a sine in the denominator. And for the cosecant, I need a sine in the denominator. Okay, so I'm going to make this -2 cosine of theta, and then over sine square theta. So I can split this up and I can make it -2 cosine of theta over, let's go ahead and take the -2 out and just write it in the front. So -2, and that's going to be cosine of theta over sine of theta times 1 over sine of theta. Okay. And then the reason I can do that is because there's 2 sine of theta. Okay. And the -2 is in the front. And then that becomes -2, and that's a cotangent of theta times, and that's a cosecant of theta. So if you look up here at the original, the right-hand side, it looks exactly like that. So that's, see, -2 cotangent of theta and cosecant of theta. One of the big things that I saw in your quizzes while I was grading it, and everybody in A-Day did well on their quiz, but I didn't count off for this. You have to have this final step where the left-hand side equals the right-hand side. You can't just go from here and say, hey, this equals -2 cotangent of theta and cosecant of theta. You can't, this will be incorrect. If you leave off this last step, then you did not finish. The left-hand side has to be exactly like the right-hand side. Okay? Good job. Okay, let's take a look at this one. Now, I tell myself which is more complicated. They're both complicated, left and right-hand side. But then the left-hand side is made up of secants. Then secants are reciprocal identities. So I can take that and make it into 1 over cosine to the 4th theta minus 1 over, okay, cosine square theta. You could do it in so many different ways, but I mean, this is the way that I chose. Okay. And then after that, I'm going to find common denominator. The common denominator is going to be cosine 4th theta. So it's 1 for that one, and cosine 4th theta, which means I just need to multiply top and bottom by cosine square theta. Okay. And then I have a 1 minus cosine square theta over cosine to the 4th theta. Okay. And then I think to myself, hey, tangents are made up of a sine in the numerator and a cosine in the denominator. I'm almost there. I could use the derivative of the Pythagorean identity and just say that sine square theta over cosine theta. Okay. And then what I could do is, since I see that this is a sine square theta right here, I can break this up, sine theta and cosine square theta times 1 over cosine square theta. Okay. And then I get a tangent square theta. I'm almost there. And then I look, okay, I got the tangent square theta. Somehow I need to get a tangent fourth theta. And it needs to be in two different terms. Okay, so how do I make this part right here? Let me go ahead and use a highlighter. This part right here more complicated than it is. And I think to myself, well, cosine square theta, I could have a 1 minus sine square theta. But then I want to turn it into two terms somehow. And then I think to myself, hey, you see this one right here? That one could be transformed into a sine square theta plus a cosine square theta. That'll give me the addition that I need, and it'll turn it into two terms. So I can go ahead and do that. Sine square theta plus cosine square theta over cosine square theta. Now I can break up that fraction, decompose that fraction, and say tangent square theta times sine square theta over cosine square theta plus cosine square theta over cosine square theta. Now I have two terms. Even though my cosine square theta and my cosine square theta is going to be equal to 1, but there's a multiplier outside and I have to distribute that to the 1. So tangent square theta times, that is going to be another tangent square theta plus 1, and then I'm going to distribute, so I get tangent to the fourth theta plus tangent square theta. And now my left-hand side equals my right-hand side. So I have verified that. Okay, good job. So on part 3, 1 through 5, which is still part of our lesson number 1 and 6.1 and 6.2, you'll find some pretty difficult proofs, algebraic proofs. I'm going to do number 4 and I'm going to do number 5. Okay, because they took the longest time for me to do, so why not? Okay, so number 4, I have to take sine of theta plus cosine of theta equals this mess right here. 1 minus cosine of theta sine of theta plus cosine of theta, 1 minus sine of theta and cosine of theta. Okay, I think this is the problem that I asked a student in advisory, and there were some 11th graders that were trying to do it, but finally the 10th grade student figured out how to do it. Okay, so the left-hand side is extremely simple. I'm going to uncomplicate the right-hand side. So first, I'm going to take those denominators and combined like terms. So sine theta over sine theta minus cosine theta over sine theta. And do it on this side too. So cosine theta over cosine theta minus sine theta over cosine theta. Okay. So I have sine theta over sine of theta minus cosine of theta, and common denominator. And I like doing things on Mr. Min's board, trying to let the 9th graders see, and the 10th graders, what they need to be able to do next year. Okay. And some of the kids were even asking, what is this? Why is there not an X? What is that little circle with a line through it? And then we have, so we're going to have a sign, and I'm going to write this out if you guys are still having trouble doing compound fractions. So you take the reciprocal of the denominator, so sine of theta over sine of theta minus cosine of theta. And cosine of theta over 1 times reciprocal of the denominator, cosine of theta minus sine of theta. Okay, that's going to be sine square theta over sine of theta minus cosine of theta plus cosine square theta over cosine of theta minus sine of theta. Okay, when I look at the two of these things, the denominators are almost the same. I could rewrite this denominator and I can make it sine of theta plus cosine of theta. They're almost exactly the same as long as I take a -1 out. So when I take a -1 out, sine of theta, that's what I get. I can take that -1 and instead of a positive, adding the second fraction to the first fraction, we're now subtracting the second fraction from the first fraction. So it becomes a minus, and then cosine square theta over sine theta minus cosine theta. And sine square theta over sine of theta minus cosine of theta. Notice that I have a common denominator. So sine square theta and cosine square theta over sine of theta minus cosine of theta. And oops, I forgot to put a minus there. Minus cosine of theta. Okay. Now this is squared. This is where it was, we did so many different ways. But then I realized all you have to do is factor. And the denominator is one of the factors. So if I factor that, theta plus as a difference of squares, what you notice is that I can just, since sine of theta minus cosine of theta is one of the factors of the numerator, that just cancels out. So I end up with a sine of theta plus a cosine of theta. And that's exactly what the left-hand side says. Sine of theta times cosine of theta. So that's going to equal. Must include that step right there. Okay? Next, let's go ahead and do number 5. Okay, number 5 took a long time for me to do. Let's just go ahead and start the problem with, I'm going to change the left-hand side. The right-hand side is very simplified. Okay? And so that is going to be sine of theta over cosine of theta minus 1 over cosine of theta plus 1 over sine of theta and cosine of theta plus 1 over cosine of theta. Okay, let's clean up the individual fractions a little bit. We have a common denominator, 1 over sine of theta minus 1 over cosine of theta plus 1 over sine of theta plus 1 over cosine of theta. Now, this is just involving reciprocals and multiplying by 1, which is in the numerator. Just take a reciprocal. Okay. Now this involves a very similar problem that we just did, which was up here. No, I lied. No, number 19. It involves where you just have to multiply the left-hand side. You just have to multiply this by the conjugate sine theta plus 1 over sine of theta plus 1. Multiply that by sine of theta minus 1 over sine theta minus 1. So that you can get a common denominator. Okay, so that just becomes, I'm just going to leave it like this over, that is sine square theta minus 1, and then plus cosine of theta sine of theta minus 1 over sine square theta minus 1. Okay, and then we can combine now, and I'm going to distribute as I combine the numerator. Cosine theta sine theta plus cosine theta plus cosine theta sine theta minus cosine theta over sine square theta minus 1. Let's see. Can we get rid of a cosine and a cosine? Yes. Do you see this? Cosine and cosine? Yep. Okay. So we just end up having a 2 cosine of theta and sine of theta. And the denominator is, I'm going to rewrite it like this. I'm going to rewrite it like that. And then I can go ahead and change the denominator. Take out a negative 1, and I get a 1 minus sine square theta. And 1 minus sine square theta is cosine square theta. Sine theta over, let me just put the negative out here, and that's a cosine square theta. Okay, and I can go ahead and simplify the cosine and cosines. So that becomes a negative 2 times, we had a sine of theta and a cosine of theta. Okay, so that's negative 2 tangent of theta, which equals all the way up to the top, the right-hand side. Once again, you must show me that last step. Okay? Good job, guys. So in part 3, okay, we're in part 3, and we're still proving that left-hand side equals the right-hand side. There is a collection of problems, part 3, 49 through 60, that involves using the double angle identities and the sum and difference identity. So you have to try these, okay? Because there's going to be identities that where you have to prove or verify that involve more than the basic identities. Okay, so I'm going to do a couple of these problems. 53. Okay, notice that we have a 2 theta in there. So that's going to involve a double angle identity. And the double angle identity that it's going to involve 2 theta equals 2 sine of theta and cosine of theta. Remember I told you that these are going to be on the test. Like I'm going to give you the formulas. Okay, but you just have to be able to apply them. Okay, so let's go ahead and I'm going to change the left-hand side. So we have 2 sine of theta and cosine of theta. And then we have 1 down here. Now we need to turn things into cotangent. So cotangent, Okay, I'm not actually changing the right-hand side. I'm just going to write it as a reference that cotangent is cosine over sine. Okay, so I could change the cosine square theta. I have two options. I could change it. The cosine of theta equals, is it 2 cosine square theta minus 1, and then 2 theta also equals 1 minus 2 sine square theta, and then cosine of 2 theta equals cosine square theta minus sine square theta. Okay, this was how we got to these two. So that was where we started, and then these two came from, the first two came from that last one. Okay, so I could use any of those if I wanted to. But then I need a sign. So I'm going to use the sign. So 1 minus that entire cosine square theta, 2 theta. I'm going to put a parenthesis around it. I'm going to put 1 minus 2 sine square theta. Okay, so let's go ahead and clean up that denominator and distribute the negative. And then 1 minus 1 is 0, so I get 2 sine of theta, cosine of theta, 2 sine square theta. Okay, the 2 and 2 simplified, although the sine is going to simplify. So we're going to end up with 1 sine in the denominator, no sines in the numerator. So I'm going to just end up with a cosine theta and a sine theta. Exactly what I needed. Okay. You can't stop here. I saw kids stopping here. You cannot stop here. This is not the place to stop. You need to keep on going. You need to have cotangent in the end. Now, that is the correct answer. Okay, let's try number 54 now. Okay, left-hand side looks pretty clean. The right-hand side looks pretty clean, but then I think I could do more with 2 terms and uncomplicate a 2 term than a 1 term. So I'm going to look at the 2 term side. Okay, tangent, just leave that as is. Cotangent, okay, that comes from the double angle identity, which is tangent of 2 theta equals 2 tangent of theta over 1 minus tangent square theta. And if I take the reciprocal of that, it'll be the same thing. Okay, so I can take the reciprocal of it. I could just, honestly, I could just flip that around and it'll just be cotangent. But to actually show you, I'm going to put 1 over tangent of 2 theta. We can include that step. Tangent of theta. If it was a true algebraic identity and I made you, if I asked you to write down all the properties for it, which I didn't, then this step would be required. But, okay. And then that just becomes tangent of theta with the reciprocal of the denominator. 1 minus tangent square theta over 2 tangent theta. Okay, we're trying to get to cosecant. We're trying to get to cosecant, which is 1 over sine of 2 theta. Okay, if you look at 1 over sine of 2 theta, okay, it's going to have a 1 term. It's going to be 1 term, 2 sine of theta times cosine of theta. So, the best thing to do is to make this into, combine left-hand side with the right-hand side. Or I'm gonna try to break the numerator up. Okay, there's multiple ways to solve this, but the way that I did it, I think I'm gonna because then I would have to have a 2 tangent. And then this first term is going to have a 2 tangent square theta, which is fine. Let's go ahead and try it this way. Okay. I'm going to do it differently than the way that my key says. So I'm going to multiply this by 2 times tangent of theta over 2 times tangent of theta to make it look like my denominator. So we have 2 times tangent square theta over 2 times tangent of theta. And I just want to simplify that to very bad, but I'm not going to, so that I can combine. Okay, and then I can now combine tangent square theta plus 1 minus tangent square theta over 2 tangent theta. Okay, one of the tangent square thetas get canceled out. So I have a 1 plus tangent square theta over 2 tangent theta. Okay. Now, let's see what I can do. Okay. Now I'm going to break the numerator up. And I'm going to put it as 2 terms, tangent of theta. Plus, remember, there's a 1 up here, tangent square theta over, is it 2 tangent theta. Okay. Let's go ahead. So cotangent becomes a cotangent. Can I split that up further and make it? Let's see, tangent theta. Okay. Cotangent. I think I could make it into a cotangent if I wanted to. But how is that going to help me? I could further break this apart and write it as 1. Okay, so that's going to stay as is. Let's go ahead and change that to 1/2 cotangent theta. And then I could just take out the tangent theta. Okay. Or let's just do what comes naturally, which is just to have 1/2 and then 1 tangent theta. Okay, so I can actually take this out and it becomes 1/2 cotangent theta plus 1/2 tangent theta. Okay, so we have a 1/2 and a 1/2 on both sides. I'm writing this too small. So we have a 1/2 equals, take out a 1/2. So we have a cotangent theta plus a tangent theta. Okay, let's go ahead and convert it now into cosine theta and sine theta plus sine theta over cosine theta. That way, 1/2 is still, common denominator is going to be sine theta cosine theta. And you see that? You see that denominator forming? That's going to be the double angle identity. And that 1/2 outside, the 1/2 outside is going to be in the denominator. The 2 is in the denominator. Okay, so we're going to get a cosine square theta plus sine square theta. When we multiply this by sine theta over sine theta, and that by cosine theta over cosine theta. Okay, so we get a 1 over sine theta cosine theta. And then I'm going to distribute the 1/2. So that becomes 1 over sine of 2 theta, which equals cosecant of 2 theta, and left-hand side equals the right-hand side. Wow, tough, huh? Okay. Good job, guys. So let's continue 57 and 58 of part 3. Okay. Once again, if you have not done part 3, you need to do part 3 to be prepared for this test. Most of the questions that I'm going to do on here is going to be from part 3. The equations and the identities proving, you might have 1 basic identity and 2 that involve the advanced identities, which is the sum and difference and the double angles. Okay. Number 57, I particularly liked because you know that the right-hand side looks more complicated, but then this 3 theta, and you think like a teacher, you think like a person who is trying to have you understand double angle identities. And you look at the right-hand side and you're like, okay, I can only do so much. I could split up that cosine cube theta into cosine square theta times cosine of theta. And then it's really not going to help you that much because, yeah, it's really not. But if I look at the left-hand side, 3 theta. Now 3 theta is, I can say, is made up of 2 theta plus theta. Okay, that is a sum. That is a sum of cosines. Okay, so the sum of cosines, cosine, we had like an x plus y. The cosine one was cosine of x, the first angle, and cosine of the second angle, subtracted by sine of the first angle and sine of the second angle. Okay, so I'm going to go ahead and rewrite it. First angle times cosine of the second angle, subtracted by sine first angle, sine of the second angle. Now, you see this 2 theta once again. I could further simplify that. But this time, I don't have to use the sum of cosines because it's a double angle identity, which is a derivative of the cosine. And so I don't really have to use that. So I'm going to use, let's see, I have a choice in cosine. I have a choice between all 3 of these. Okay. But I can use a sine or I could use a cosine. My thought is to use the cosine because the right-hand side has all cosine in it. But if you look, there's sines here on the second term. I created some sines. Okay. And if you think and plan, if I have more cosines there, it's going to just turn it into a cosine like cubed, possibly, okay? I don't want that to happen. I want to somehow be able to turn that into cosines too. So On the key, I use a sine, but I might regret this, and this might become a really long video, but I'm going to try to use this cosine on it. I'm going to use a 2 cosine square theta. Okay. 2 cosine square theta minus 1. Why? Because I just live dangerously. Okay. 2 sine of theta and cosine of theta. There, you don't have a choice for the double angle for sine. There's only one right here. There's only one. Okay. And then I'm going to distribute 2 cosine cube theta minus cosine theta minus 2 sine theta cosine theta sine theta. Okay. Now what do? I think I'm in trouble. Oh no, I can do a sine squared theta. Okay. We have a sine and a sine. Cosine cube theta minus sine theta minus 2 sine squared theta and cosine theta. Now, if I had instead of that 2 cosine squared theta, I had a 1 minus 2 sine squared theta, I could have actually factored out a sine squared theta. So I kind of messed up, but you know what? I think I'll be okay. Okay, I think I'll be okay because I think I can split. Couldn't I make this 1 minus cosine squared theta? Let's try that. Because I have a cosine cube theta on the right hand side. So 2 cosine cube theta minus cosine theta, distribute -2 plus, wait a second. If I do that, then I have to distribute this entire thing. Let's rewrite this. I messed up right here. It's supposed to be a -2 cosine and then minus cosine square theta. Okay. So that's a -2 cosine theta minus or plus 2 cosine cube theta. Okie dokie. I got it. 2, you have a cosine cube theta. That's 4 cosine cube theta. We have a -1 and a -2 minus 3 cosine of theta. This one actually took shorter than the other way that I did it. Match it to the right hand side. There you go. Left hand side equals the right hand side. Good job, guys. 58. Okay. 58. Now this, it has alphas and betas in it. Don't you just love the Greek alphabet? Okay. The alphas and the betas. So I'm just going to straight use the sum and the difference of the cosine. Okay. Let's see. It's the sum of cosines, cosine of alpha, cosine of beta, minus sine of alpha. I hate writing and the beta. Minus, put a parenthesis around it. You need to distribute that -1. Okay, if this whole problem is devoted to teaching you to distribute the negative sign, okay, then that's it. Okay, cosine of alpha, cosine of beta plus sine of alpha, sine of beta. Now I have cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Distribute cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. This whole problem is devoted to just distributing that -1 through. I truly believe that. Okay, you have a cosine of beta, alpha and a beta, cosine of alpha and beta. Those will cancel out. And then we have a 1, -1, and a -1. So that's going to be -2 sine of alpha, sine of beta equals the left-hand side. Check. Good. Good job. Okay. Next problem. Okay, I think this just involves just utilizing those cosine and sine sum difference. Okay, and it's really not going to, I'm just going to delete that. It's just, if you know how to do those, then you should know how to do the rest. So 6.3 involved equations. Okay, it involved finding all possibilities of the equation. So part 3, 6 through 14, notice that this only has part 3 in it. So if you did not do part 3, you're going to be big trouble because you are not going to know how to do any of these equations. Well, possibly from our lesson, but that was a long time ago. So you really, really need to do part 3. I cannot stress to you how important it is for you to do part 3. Okay, let's go ahead and find these equations. I'm only going to do some of them. Okay, so this is bothering me. Okay, so this involves 6 through 14 are basic. It's not going to involve you using the advanced identities. The 33 through 42 and 70 through problem 72 through 83 are going to involve the advanced sum and difference and the double angle. Okay, I'm just gonna do, let's see, just stepped away, and I'm gonna do these circled problems. Okay, number 9. So we have a cosecant square theta equals 2. Okay, so these problems you have to figure out what theta is, all the things that theta could be, what angles theta could be. So I'm going to square root both sides. I mean, in most cases, if it's all of these problems, this one, this one, this one, this one, those 4, it doesn't have terms with multiple tangents or multiple trig functions in it. The rest of them, well, except for this one and this one, the 3 and the 10, 11, and 12 have terms with trig functions in it. And so for 6, 7, 8, and 9, you just have to square root both sides. The square root, remember we get the plus or minus over 2. So that's going to be cosecant of theta equals plus or minus square root of 2. And you can use it in this manner right here. Or you can change it into, and that could be 1 over sine of theta. So that'll be 1 over plus or minus square root of 2. So sine of theta equals plus or minus square root of 2 over 2. Okay, so we're looking at all the sine of thetas where it's square root of 2 over 2. So if I look on my unit circle, it's going to be pi fourths and 3 pi fourths. Pi fourths and 3 pi fourths. Okay. What am I doing? Actually, it's all of the all of them because it's plus or minus. So if I look, it'll be pi fourths and 3 pi fourths and also 5 pi fourths and 7 pi fourths. It's going to be all of those angles. These two are going to be plus square root of 2 over 2. And these two are going to be minus square root of 2 over 2. Okay. So I know that between pi fourths and 5 pi fourths, it's a pi distance. And then I know between 3 pi fourths and 7 pi fourths, it is pi distance. So I can just make two equations with a difference, with a difference between them as pi. Okay. I think I might have gotten the key wrong. Yeah, I don't know. I think I might have gotten the key wrong. But anyways, okay. No, the key's not wrong. I'm sorry. There's things going on in my house today. Kind of distracted. I'm always distracted. But anyways. Okay, so I can make two equations with the pi distance. Okay, and so that's pi fourths plus pi k. K is an element of all real numbers. Theta equals 5 pi fourths plus pi k. K is an element of all real numbers. Okay, because the first equation is going to encompass all of the pinks. Okay, and their multiple revolutions. And the second equation is going to encompass, no, that's not 5. Why did I write 5? That's a 3. Okay, a second equation, the 3 pi and the 7 pi. Okay, good job. Number 10. Number 10 says tangent cubed theta plus 2 tangent square theta plus tangent theta equals 0. 3 terms with a 0 set equal to 0. Factor. Okay, factoring. So how do we factor this? First of all, I could take out a tangent theta in all of them. So I'm going to get a tangent square theta plus 2 tangent theta plus 1. Okay, so I already know it could be tangent of theta equals 0. And then tangent square theta plus 2 tangent theta plus 1 equals 0. Now I can factor this. Looks like a perfect square trinomial. Tangent theta plus 1, tangent theta plus 1. So I could just take one of this, and tangent theta equals -1. And you're just going to get a double multiplicity. Okay, so it's not necessary. So if I look at what theta could be, theta needs to be a 0. So that means it could be 0, angle 0, radians, pi. And then when I apply it to the -1, what it could be for -1, it could be, oh, whoops, 3 pi over 4 and 7 pi over 4. Okay. Once again, I could just make two equations for tangents. These two with a pi distance between them, and these two. So theta equals 0 plus pi k. K is an element of all integers, or 3 pi over 4 plus pi k. K is an element of all integers. Okay. Good job. I'm going to do one more right here. Number 11. Number 11 is 3 cosine of theta plus 3 equals 2 sine square theta. Okay, for this one, we have to use the basic identity. You notice that it has a cosine on the left-hand side. So I'm going to change this into 1 minus cosine square theta. So that becomes 3 cosine theta plus 3 equals distribute minus 2 cosine square theta. Move everything to the left-hand side. So I get a 2 cosine square theta plus 3 cosine theta, and then a minus plus 1. Okay, now I just need a factor. I mean, you could use where you could say a equals cosine of theta if you want, or if you feel comfortable just factoring the way it is, then factor the way it is. Okay. So you're going to get 2 cosine of theta and a cosine of theta. And you're going to have to, it's going to be the same signs and a 1 and a 1. And that's going to produce a 3 in the middle because 2 times 1 plus 1 is 3. Go ahead and do 2 cosine of theta plus 1 equals 0. And cosine of theta plus 1 equals 0. So cosine of theta equals negative 1/2. And cosine of theta equals negative 1. Okay, so for cosine of theta to be negative 1/2, you're going to need theta equals, you're going to have 2 pi over angle 2 pi over 3, 4 pi over 3. For theta to equal, cosine for it to equal negative 1, that's going to be just pi. Okay, 2 pi over 3 and 4 pi over 3 are not pi distance away from each other. So you need 3 equations. Okay, with a 2 pi added to it each time because we're just doing revolutions now. Okay, so your angles are going to be equals 2 pi over 3 plus 2 pi k. K is an element of all integers. 4 pi over 3 plus 2 pi k. K is an element of all integers. Equals pi plus 2 pi k. K is an element of all integers. Okay? Good job. Number 12. Let's go ahead and make some room for number 12 and 13. Okay. Number 12. I think there was a completing the square problem amongst of these where you had to complete the square. I'm not going to do that one. Okay, it's not going to, completing the square is not going to be on the test. Okay, so we have 2 cosine square theta plus 2 sine of theta plus square root of 3 sine of theta equals 2 plus square root of 3. It looks like a bunch of mess, huh? Well, first I'm going to move the 2 terms on the left-hand side, the 2 terms right here, and move it to, the right-hand side and move it to the left-hand side. I already know that cosine square theta is going to become a problem, so I probably have to use my basic identity and change it. Minus 2 minus square root of 3. Okay. So let's see. Am I missing something? Oh, no, not really. Okay, well, there's a 2 here and a 2 here. Well, let's go ahead and factor out the 2. Or I can just start by making this 1 minus sine squared theta. That's going to create the 2 for me. Because I'm trying to get rid of that minus 2, the negative 2. So that's going to be 2 minus 2 sine square theta plus 2 sine of theta plus square root of 3 sine of theta minus 2 minus square root of 3 equals 0. We have a 2 here and a minus 2 that's going to cancel out. And so I have a minus 2, okay, sine square theta plus 2 sine theta plus square root of 3 sine theta minus square root of 3 equals 0. I have 4 terms. When you had 4 terms and you need to factor, you factored by grouping. Okay, so you can group these 2 and you can group these 2. I can take out a negative 2. I could take out a negative 2, and I can also take out a sine theta. So I ended up having a sine of theta minus, because I took out a negative 2, 1. From the second group, I'm going to take out a plus square root of 3. So I have a sine of theta minus 1. From these 2 groups, I can take out a sine of theta minus 1. When you're factoring by grouping, you're dividing both of the terms by sine of theta minus 1. And then what you're left with is negative sine of theta plus square root of 3 equals 0. So you get sine of theta minus 1 equals 0. And then negative 2 sine of theta plus square root of 3 equals 0. So we have a sine of theta equals 1. And we have a sine of theta equals negative square root of 3 over negative 2. So it's going to be that. Okay, now let's figure out what all of our thetas could be. Theta for 1, the only thing it could be is pi over 2. Y theta is square root of 3 over 2, could be pi over 3 and a 2 pi over 3. None of those are pi distance apart, so I need to have all 3 equations represented with a 2 pi distance away from each other. Integer and there you go. Okay. Last but not least, number 13. Okay. We have square root of 2 and a cosine of 5 theta equals 1. Okay. So I know we learned the double angle identities, but it's really not going to help you much in this situation unless we get it down to a theta. And so you could say, hey, you know, it's made up of 3 theta and 2 theta. And then you can say, hey, 3 theta is made up of a 2 theta and a theta. And then you can say 2 theta is made up of a theta and a theta. You can make the most complicated problem in the world, guys. Let's not do that, okay? So the way we do this is just divide by square root of 2. So cosine of 5 theta equals 1 over square root of 2. When I rationalize the denominator, I get square root of 2 over 2. Okay. Now, remember, we take 5 theta and we just take 5 times the angle. And where does it land as the x value being square root of 2 over 2? And that's going to be pi over 4 and 7 pi over 4. Okay, so I'm going to write an equation for both, keeping in mind that this is not theta. This is 5 times the theta. So pi over 4 and those are not, these two angles are not pi distance away from each other, so I need to represent them in two different equations. And then I could take this and I can say, I can multiply this by 1 over 5. And I can multiply that by 1 over 5, 1 over 5, and 1 over 5. So I get theta equals pi over 20 plus 2 pi 5k. K is an element of all integers. That's going to be 7 pi over 20 plus 2 pi over 5 k. K is an integer of all, element of all integers. Okay. Number 14 is very similar. Okay, good job, guys. There's a whole bunch more. I think I'm going to do number 35, maybe 42. Okay, I'm going to do 35 and 42. I'm just going to, you can skip through, but these are different style of problems. 3 terms. Okay, I think this one involves double identities. No, this is just, this is not advanced. Not yet. Okay, I lied. These are not advanced. Okay, you can just factor. So 2 sine of theta, 2 sine of theta. Is it? Plus 3 minus 1. That does not give you a 4. Yes, it does. 6 minus 2. Yeah. And then you get 2 sine of theta minus 1 equals 0. And 2 sine of theta plus 3 equals 0. So you get sine of theta equals 1/2. And sine of theta equals negative 3 over 2. Oh, maybe the reason I wanted to do this one is because this is negative 1.5 sine of theta. And that can't be, because y cannot be less than negative 1, nor can it be greater than 1, because it'll be outside of the unit circle. So this one does not apply. So the only thing that it could be is theta equals pi over 6 and 5 pi over 6. And then they are not pi distance away from each other. So pi 6 plus 2 pi k. K is an element of integers. And 5 pi over 6 plus 2 pi k. K is an element of all integers. This is the completing the square one. You can't factor that. You have to complete the square. Or that'd be interesting if you could use the quadratic formula, but you probably can. But let's not do that. Okay, I'm not gonna be asking you to do that. 42. Once again, these don't involve. Yeah. Once again, this one, I mean, you want to change it into 1 minus cosine squared theta plus cosine of theta plus 1 equals 0. So you get negative cosine squared theta plus cosine of theta plus 2 equals 0. I do not like factoring by a leading coefficient of -1. I'm pretty sure you guys, some of you guys can do that. So I just factor out a -1 and then divide it by, move it to the other side, and it becomes 0. And you end up with a cosine of theta minus 2 and a cosine you can factor plus 1 equals 0. So you get cosine of theta equals 2 and cosine of theta equals -1. Once again, this is not going to work. Does not work outside unit circle. So the only thing that it is pi. So theta equals pi plus 2 pi k. K is an element of all integers. So here's me doing this over again. I had highlighted the ones that I wanted to do. And then I realized that I pushed the enter button. So it took me to different problems. Anyways, okay, these are the problems that I want to do. These involve solving for the angle with all of the advanced identities. I highly recommend you do these set of problems, okay? Number 72. Okay, it says cosine squared theta minus sine squared theta equals 0. And if you look at the double angle identities, and I don't think we really went over this one, but if I scroll up here, and I'm going to give you these, that is the basis of cosine 2 theta. And the other two are derived from there. Okay, so I can just straight, when I see a subtraction instead of an addition, I can say that that's cosine 2 theta. But if you don't know that, then I can always take one of them. It doesn't matter. I can take this one, make it into sine squared theta minus sine squared theta equals 0. So that ends up becoming 3, and then that's a sine squared theta equals 0. You could have taken it and make it a cosine. Okay, and wait a second. This is wrong. This is a 2. That's a 2. And that just becomes the cosine as a double angle. And I could take 2 theta and see where x equals 0. The only place where 2 theta is going to be is pi halves. Okay. And so I can go ahead and, cosine is pi halves and also 3 pi halves, right? X is 0. Yeah. So they're pi distance away from each other, so it's going to be pi halves plus pi k. K is an element of all integers, so I'm going to take the left-hand side and multiply it by 1/2. I'm going to right-hand side multiply it by 1/2, so I get theta equals pi over 4 plus pi halves k. K is an element of all integers. Okay. Next, so I'm going to do 73. 73 is sine of 2 theta equals 2 cosine squared theta. I'm going to go ahead. Sine squared theta is going to be 2 sine of theta cosine of theta equals 2 cosine squared theta. Okay, set the right hand side equal to 0. 2 sine of theta cosine of theta minus 2 cosine squared theta equals 0. Let's go ahead and factor out a -2 cosine theta. So I'm going to get a negative sine of theta, and a positive cosine of theta equals 0. Okay, you can split this up, -2 cosine of theta. I know there's 2 trig functions in there, but when I see a sine of theta and a cosine of theta, I could move a term to the other side and then divide by it. And then that side becomes 1 and the other side could become a tangent or a cotangent. Okay, so I could find tangents and cotangents of angles if I'm given it. Okay, so equals 0 and negative sine of theta plus cosine of theta, as long as there's not two signs in it. If there's two signs in it with differing powers, then I have to still factor. Okay, but this case, it's just two terms, and I can take it into this. I can make this into cosine of theta equals sine of theta. And then I could divide both sides by cosine of theta. So this side becomes 1, and that just becomes tangent of theta. Okay, I could just divide this by -2. So the other one is cosine of theta equals 0. So where theta with a cosine equals 0 is going to be pi halves. It's the same as this one right here. Pi halves and 3 pi halves with the pi distance away from each other. And then where tangent is 1 is theta equals pi fourths. And then the other one, 1, 2, 3, 1, 2, 3, 5. 5 pi over 4. Sorry, pi over 4. Okay, with a pi distance away from each other. So I could just write a, oh, my laptop's really slow. I'm processing another video. Okay, and so theta equals pi halves plus pi k. K is an element of all integers. Theta equals 4 plus pi k. K is an element of all integers. Okay, good job. Okay, so let's go ahead and do number 76. That's 4 cosine of 2 theta equals 8 sine of theta cosine of theta. As soon as I see this, I know that I can use a double angle. Okay, and that's 2 theta. So that could be turned into a sine of theta. Okay, but the equation is that it's sine of 2 theta equals 2 sine of theta and cosine of theta. And there were some exercises where you had to find like A and B, where you had to turn it into that, or you had to understand that this is actually 4 times 2 sine of theta and cosine of theta. And then you can take this 2 times, and that becomes sine of 2 theta. So you're just multiplying that by 4. Of cosine, whoa, this is, I'm not liking this at all. Okay, so cosine of 2 theta and 4 times cosine of 2 theta. So when you have this situation, you can do it like just like 73, which is divide both sides by 4 cosine of 2 theta, 4 cosine of 2 theta. So you end up having 1 equals 4 divided by 4, and then you have a tangent of 2 theta. So you can say theta of 2 theta, where 2 theta is 1, where the places that 2 theta is 1 is pi fourths and 5 pi fourths. Yikes. My laptop's slow. It's processing a video while we're doing this. Divided by 4, and it just ran out of battery. Hold on. Pause. Man. 5 pi over 4. So 2 theta with a pi distance between them, right? So we could just pi over 4 plus pi k. K is an element of all integers. And then I can multiply this by 1/2. I can multiply this by 1/2. So theta equals pi over 8 plus pi over 2 k. K is an element of all integers. Okay? Good job. So we'll have to do 79. 79. Sine of 4 theta minus sine of 2 theta equals 0. Okay. I can take out a 2 theta. Let's go ahead and take out 2 theta. So you get a sine of 2 theta minus 1 equals 0. And so you have sine of 2 theta equals 0. Sine of 2 theta equals 1. And then you have to figure out where 2 theta equals 0. And so for 0, that's going to be 0. Y is 0. And pi. For 2 theta, where it equals 1, is... interesting. Oh, I did it a different way. I wonder if this way works. Okay. Okay, I just factored it out instead of actually using... I'm looking at what I did. Let's just try it this way. Where equals 1. Y equals 1. The only place where y equals 2 theta, where y equals 1 would be... Yeah, I don't think this is going to work. Yeah, I don't think this is going to work because I know what the correct answer is. And so the only way where y is 2 theta would be pi halves. But then pi halves, when you multiply, it becomes pi fourths. It doesn't produce 2 angles. So no, this is not going to work. This does not exist. You cannot do this. Because if you had a... how would I explain that? If you had 4 times an angle subtracted by 2 times an angle, doesn't mean that, well, you could have it where it's 2 times 2. This is made up of 2 of the angles. You can say that. Yeah, I'm trying to explain why it would not work, because that's like saying sine of 3 theta plus theta, and that's like saying sine of theta plus theta. And then it turns into, because these are not the same angles, it turns into a completely different formula. So this is, I can't just simply take out 2 theta. And I wish it was the case, but okay. So what do you go from here? You can say that we can take that and say that's 2 times. We're going to use this as double angle. It could be 2. Yikes. 2 times 2 theta. Okay, so this entire thing would be the double angle. So 2 times sine of 2 theta and cosine of 2 theta minus sine of 2 theta equals 0. My laptop is getting super hot. Okay. It was a mistake. It might blow up. Okay, it's a brand new laptop. I should have listened to my brother when he said don't buy a Surface. Don't buy a MacBook. But the MacBook that you could touch Surface one is pretty expensive. Okay. And he worked for Microsoft. Okay, that's really funny that he would tell me to buy. Don't buy Windows products. Anyways, okay. So I could take out a sine theta, sine 2 theta. Okay, and I get 2 cosine of 2 theta minus 1 equals 0. Okay, in that case, I could do that. And so that would become sine of 2 theta equals 0. And 2 cosine of 2 theta equals 1. I'm just going to say cosine 2 theta equals 1 over 2. Okay, so for 2 thetas here, it'd be 0 and 2 pi, right? And then for 2 thetas here, cosine would be 1/2, which would be pi over 3 and 5 pi over 3. This is a pi distance away, so I can write one equation. Pi, k is an element of integers. Those two, pi 3 and 5 pi 3, are not pi distance away, so I have to write 2 plus 2 pi k. K is an element. 2 pi equals 5 pi over 3 plus 2 pi k. K is an element of Z. And then I'm going to multiply all of them by 1/2. So I end up with theta equaling K. K is an element of Z. This one is going to be theta equals pi over 6 plus pi. 2 divided by 2. Pi is going to just be pi. Okay, theta equals 5 pi over 6 plus pi k. K is an element of all integers. Okay, my laptop is getting so hot right now. Best thing for me to do is solve the final problem and then see how the processing is going. Sine of 2 theta, cosine of theta, minus cosine of 2 theta, sine of theta equals 0. Okay, if you look at this equation, we have a sine of the first angle and a cosine of the second angle, cosine of the first angle and the sine of the second angle. So that would be the sine formula. Sine for, let's say sine for x plus y equals sine of x cosine of y, and then minus, this would be a minus cosine of x sine of y. And that's the formula that I need to use. Okay, so when I identify that's the first angle, right here, that's the first angle. Theta is the second angle. Okay, and then I could put it into that formula and condense it. So it becomes 2 theta minus theta equals 0. Okay. And then that just becomes sine of theta equals 0. So I figure out where is my thetas that are, then that's going to be 0 and pi with the pi distance away. So I could say pi k. K is an element of all integers. Okay, good job, guys. Oh, this wrap-up video is going to be long.